a bell box is considered dust-tight. This means it is designed to prevent dust and other solid foreign objects from entering the enclosure and potentially damaging or interfering with the electrical components housed inside. The dust-tight characteristic of a bell box is achieved through several design features and material choices. Firstly, bell boxes are typically constructed from durable materials such as metal, often steel or aluminum, or rigid plastics. These materials provide a robust barrier against the external environment. Secondly, the enclosure is designed with a tight-fitting cover or lid that seals securely against the box body. This seal prevents dust particles from infiltrating the interior. The seal is often achieved using gaskets or similar sealing materials that compress when the cover is fastened, creating a positive barrier. Thirdly, the entry points for wiring or conduit are also designed to maintain the dust-tight integrity of the enclosure. This is often achieved through the use of threaded conduit entries or compression fittings that seal tightly around the wires or conduit entering the box. The dust-tight rating of an electrical enclosure, including a bell box, is often indicated by its NEMA, which is National Electrical Manufacturers Association rating, or its IP rating, which is Ingress Protection rating. NEMA ratings are commonly used in North America, while IP ratings are more prevalent in international standards. For example, a NEMA Type 4 enclosure is considered dust-tight and also provides protection against splashing water, while a NEMA Type 12 enclosure is dust-tight and also protects against dripping non-corrosive liquids. IP ratings consist of 2 digits, the first indicating protection against solid objects, including dust, and the second indicating protection against liquids. An I6 rating, for example, indicates that the enclosure is dust-tight. The XNI6 is a placeholder for any level of liquid ingress protection. The selection of a dust-tight bell box is important in environments where dust is prevalent. This includes industrial settings, manufacturing facilities, construction sites, and agricultural environments. In these locations, dust can accumulate on electrical components, leading to overheating, reduced performance, and even equipment failure. By using a dust-tight bell box, the risk of these problems is significantly reduced. Firstly, it is to identify the specific environmental conditions in which the bell box will be used. This includes the type and amount of dust present, as well as any other environmental factors such as moisture, temperature, and corrosive substances. Secondly, select a bell box with a NEMA or IP rating that is appropriate for the identified environmental conditions. Consider the level of dust protection required, as well as any other protection needed, such as water resistance or corrosion resistance. Thirdly, inspect the bell box for any signs of damage or defects before installation. Ensure that the cover or lid fits tightly and that all seals are in good condition. Fourthly, use appropriate wiring methods and fittings to maintain the dust-tight integrity of the enclosure. Use threaded conduit entries or compression fittings to seal tightly around wires or conduit entering the box. Fifthly, periodically inspect the bell box to ensure that it remains dust-tight. Check for any signs of damage or wear and tear, and replace any damaged or worn components. Sixthly, clean the bell box regularly to remove any accumulated dust. Use a vacuum cleaner or a damp cloth to remove dust from the exterior of the enclosure. Ensure that the cover or lid is securely fastened after cleaning. Failing to properly maintain dust-tight integrity can result in compromising the protection of electrical components, leading to potential hazards such as electrical shorts, fires, or equipment failure. In areas with high dust levels, the accumulation of dust inside electrical enclosures can act as an insulator, trapping heat and causing components to overheat. This can lead to premature failure of sensitive electronic components and increase the risk of electrical fires. Dust can also interfere with the operation of moving parts, such as switches and relays, causing them to malfunction or fail altogether. In addition, dust can be abrasive and can wear down the surfaces of electrical contacts and connectors, leading to poor electrical connections and increased resistance. Poor electrical connections can generate heat, further exacerbating the problem of overheating and increasing the risk of electrical fires. To address these issues, it is important to select electrical enclosures that are specifically designed to be dust-tight. These enclosures typically have features such as gasketed doors, sealed seams, and filtered vents that prevent dust from entering. In addition to using dust-tight enclosures, it is also important to implement proper maintenance procedures to keep dust levels under control. This may include regularly cleaning the enclosures with a vacuum cleaner or compressed air, as well as using dust collection systems to remove dust from the surrounding environment. It is also important to ensure that all openings in the enclosures, such as cable entry points, are properly sealed to prevent dust from entering. In some cases, it may be necessary to use specialized dust-tight connectors and fittings to ensure a complete seal. By taking these steps, it is possible to minimize the risk of dust-related problems in electrical systems and ensure that they operate safely and reliably.